Hi, my name is Daniel Garcia, and our project is a catapult. Our basic design for this catapult is a combination of a photodetector detecting infrared light, an infrared light emitter which connects to a servo which winds up a string, triggering the catapult to launch. Later in the video, Abdullah and Jeff will go into more detail about how the exact circuitry works and how the digital logic works, but I'm here to explain some of the early ideas that we had, some of the trials and some of the challenges we've had in building this catapult. So initially, we had the idea of creating a launcher of some sort, but one of the problems we encountered was whether or not it should be a catapult, whether or not it should be some sort of spring-launched, spring-loaded gun. After deciding on a catapult, we split up the next few weeks into the electrical component and the mechanical component of the project. We were able to create a simple circuit and eventually had a motor running that was activated by infrared light. In the next 2 labs after that, the circuitry for the electrical part stopped working for whatever reason. We had the second idea of having some sort of digital logic implemented where the infrared light would be shown at the photodetector and it essentially would hold the state of the circuit. This would remove the need for us to hold the infrared light onto the photodetector to wind up the servo. Shining the infrared light would allow the circuitry to retain its state for a few seconds. Jeff or Abdullah will go into that in more detail later in the video.
Hi guys, my name is Jeff. This is our project. The first part of our project is a simple circuit. It's essentially a resistor connected in series with a IR sensor to a 5 volts power source. The IR sensor is basically a switch. So when I shine IR onto it, the switch is closed, and the voltage across the resistor is 5 volts. But if not, the voltage across the resistor is 0. And we output this voltage across this resistor to our next system. So using LabVIEW, I'm able to implement a system with 2 states, the 0 state and 1 state. Initially, the system has input 0, and it stays in 0 state and outputs 0. Whenever it detects 5 volts as input, it goes from 0 state to 1 state. And in 1 state, the system is going to output 5 volts for 2 seconds, and then 2.5 volts for another 2 seconds, and after that it goes back to 0 state. So LabVIEW controls the input and output on the MyDeck using a software called Deck Assistant. The input of the Arduino comes from the output of LabVIEW. Basically, the Arduino supplies power to the servo and controls its direction. When the input voltage is 5, the Arduino controls the servo and make it turn right. When the input is 2.5 volts, the servo turns left. When the input is 0, the servo stays still.
Hello guys, my name is Abdullah and this is our project. So the output of our control system, the Arduino, goes into the motor. The motor is connected to a wire and is connected to the catapult through the magnets right here. So for 2 seconds, the motor turns to the right. The wire through the magnet pulls the catapult, and then when the force of the wire is stronger than the magnetic force, the wire splits and the paper ball is launched. And after that, for 2 seconds, the motor is turned to the left, and then it goes to the reset state. Okay, so the servo is made in this manner so that we don't need to reset the motor every time the catapult is launched. It turns to the right for 2 seconds and turns to the left for 2 seconds, and then it just goes back to the initial state.